I just wanted a huge thank you to Motorsports. They're opening up their place to us, and they've provided the pizza and the drinks, and so I just wanted to say thank you to those guys. I think a round of applause, absolutely. So thank you guys, I appreciate it. All right, so the first talk I'll be giving is on demystifying TDD, test-driven development. And then following that, Sheldon's going to give a talk on algorithms. So we'll just go ahead and get started with this, and then maybe have a 15-minute break, and then we'll get him rolling. So, test-driven development. Well, first let me talk about myself, just so you know who you're getting your advice from. I work for a company called CDK Global. I recently became I'm calling it a division software architect, since you don't really know the ins and outs of CDK, but basically I oversee just the technology behind a bunch of different products. I'm a Zen certified engineer, been software engineering for about 12 years. Most of that's actually been in PHP, although more recently it hasn't been, but that's where my roots are, so I still love it, and it always comes back to that, and so that's what keeps me going with this meetup. So what I'm going to talk about is basically getting you guys to be test evangelists. I want you to leave here basically going back to your teams, if you work in a team or if you work by yourself. I want you to go back and never not write a test again. And whether it's through TDD or not, I'm going to show you that avenue to write tests, and I'm also going to show you the advantages of writing your tests first as opposed to writing tests later. So that's my hope when you guys walk away from this talk. What we're going to go over is kind of what is test-driven development. Why choose test-driven development over writing your tests afterwards or not writing tests at all, or even manual testing. And then I'm going to do a live kind of coding example. I don't like to just stand up here and talk. I'm not very good at it. But I'd like to show you kind of how easy it is to get into it. And then hopefully you can take that back and run with it. What we're not going to cover is some of these things. So I'm not going to tell you how to install PHP unit. There's a lot of good documentation on there, and I think there's even other talks on how to install that. We are going to use a composer to install PHP unit in my example, but I've given composer talks. Hopefully you guys have seen those, and if not, again, it's one of those things where a little Google searching, and I think you guys can figure it out. So in order for time, we're just going to skip over that stuff. I'm not going to talk about how to get tests running in your IDE. Everyone has a different IDE. And so, how you actually hit go and run your tests, or whether you do it from the command line, or that's your personal preference. So we're not going to go over actually hitting, go and run your tests. We're mainly going to talk about the tests themselves, and that's what we're going to go over. So what is TDD? So Kent Beck, basically, I think people mostly think of him when they think of TDD, but he often says that he rediscovered TDD. He doesn't say that he discovered it or invented it, but he rediscovered it. He said basically that the original description of TDD was in an ancient book about programming. It said you take the input tape, manually type in the output tape you expect, then program until the actual output tape matches the expected output. I'll let you guys read the rest of that, but basically it's something that's been around for a long time, and once he kind of figured it out, he rediscovered TDD, and he built XUnit. So that's kind of how it kind of got back into the mainstream. How does it work? Well, this is the crazy example that I got off of Wikipedia. But it's a little bit more simple, I think, than this. I think this is exploding it out. But we'll go over it. It's basically write the test before you do any code. It's going to fail because you're writing the test. When it fails, then you write the code to make it pass. Run the test again. If it fails, keep writing code. Until it passes, then clean up the code, and then repeat. Oop. There we go. A simpler way to say it in 3 steps is write test, make a pass, then refactor. I like that better. It's a lot simpler. Why do you write the test first as opposed to second or last? You'll actually write them. By show of hands, who says, I'll write tests later and then doesn't write the test? It's probably half the room. And the rest of you are liars. They're actually more meaningful when you write them first. And if you think about the tests that you write afterwards, if you really think about it, I'll bet you're writing tests for code that's already been written. So you're writing tests to test that it does what it does, not what it's intended to do. And so by that very nature, when you write those tests, it's not going to be as beneficial. Testing is a good way for other programmers to actually look at what the code's supposed to do, not what the code does. And so you'll see examples of that in the live example. I'm going to show you some tests that I wrote that I might have written if I wrote it afterwards. And then we're going to actually go through a TDD example of writing the test first and see what kind of tests come out of that. And then you guys can decide which tests you think are better. Some people think it's more productive. In the book on the effectiveness of test-first approach to programming, it said that they found that the test-first students, test-first development is another way of saying TDD, on average wrote more tests, and in turn, students who wrote more tests tended to be more productive. So it's not something that is going to, slow you down. It might slow you down in the beginning, but over the long haul of the complete system that you're writing, it will actually speed up development because you're not going to be breaking things. And it actually drives the design of the program. When you write your tests first, you have to think about the interfaces and not necessarily the implementation of the code. And again, in the examples that I'll show later, you'll see what I mean by that. So, if I've sold you, then how do we start? Okay, so for the live coding example, this is the story. If you're in an agile shop, then you might get a story from your product owner or your product manager. And in this scenario, the background is you work for a company that sends marketing emails to clients. And the story is, as a subscriber, I don't want to have to scroll horizontally to read plain text message so that I can read the message easier. So if it's like a non-HTML message, if it's just a text message, and it's running off on the side of the page. So basically, we need to be able to add some line breaks after a certain line length. I had to think of something that I could fit into a talk, so this is what I came up with. Yeah, TDD helps you achieve a better design, but it does not eliminate the need for upfront design and thinking. So you still have to kind of think of, okay, so that's the story. How am I going to design this? What am I going to write to actually get this thing rolling? In this kind of simplistic example, you have to write, some sort of a class that takes in an input and it has a line length, and we'll wrap it. So let's get started. Sorry, I'm going to be over here, but you can look up there. Let's see here. Mirror the displays again. All right. How's that looking? Hopefully this won't be too small for you guys, but so we got the story. We basically need to write a wrapper, and hold on, I forgot. I have some notes here because I'm screen sharing. I forgot to pull the notes out. There we go. This keeps me on track. All right, so like I said, I'm not going to talk about installing PHP Unit or Composer. You can see I have Composer already in here. Really quickly, I'll just show you, I've got PHP unit as a development requirement. I've added some auto loading for my source and my tests folder under the TDD and the TDD test namespace. So just got that kind of preliminary stuff out of the way. And let's write our first test. So right off the bat, oopsie, I'm going to add some namespaces since I put this in the TDD test namespace. I'm going to make a text namespace under that and write a wrapper test. The class I'm going to write is just going to be called wrapper. All right, so here's my test. First test I'm going to write that's going to fail. I want to test that I can create wrapper. So I'm going to say wrapper equals new wrapper. Assert the instance of, and I've already defined the namespaces, so in this scenario it's going to be TDD text wrapper. So in my design, I've defined that I'm going to make a wrapper class, and I'm going to put it in the text namespace, well, the TDD text namespace. I'll put a use statement up here, TDD, oopsie. And I've already set up running it in my IDE. Like I said, I wasn't going to go over that, but if I run it, the first failure I get is that, of course, it can't find the class. So I'm going to go ahead and create the class. All right, so it's passed. So the first test is complete. Let's see. The next test that I want to do is it's supposed to wrap a string. So I might think of some of the edge cases. What if I pass in a blank string? So test can wrap empty string. Oopsie. And I'm just going to say this assert equals that maybe when I call a wrap function and I pass in an empty string, I'm going to assert that it comes back empty. All right. Well, let me run it first. Right? It fails, of course. The wrap function doesn't exist. So I'm going to add that method. Add that to text or something. Run it again, and it passes. That test is complete. It seems silly. It seems like I'm not really writing anything. But this is forcing me to write a test for what it's supposed to do. If I leave the test as it is, then I haven't really, and I start writing more code here, I haven't really written a test for the code I'm writing. So let's go with another kind of simplistic example. Test can wrap, I don't know, small string. And in this example, in fact, actually, you know what? I can already see the third step to TDD is refactor, right? And that includes your tests. I'm already seeing some duplication here. With PHP Storm, PHP Unit, you have a setup function. That gets run before every test. So I can ditch that, and now I can just use this wrapper. That way I don't have to make that call every single time. It's a little bit easier. All right, so, oopsie, can wrap small string. So in this case, if I put in a word and I say you know, I want it to wrap 5 characters. 1, 2, 3, 4. Well, that goes beyond it. I expect that it's going to come back with wrap. Okay, that fails, of course, because I'm not actually returning anything, so I'm going to make that pass. First thing I need is the line length. And you could go as simple as just saying text. So now it's whining because I don't have a second parameter up there, so that's fine. So I'll just put a default up here. Ah, no one caught that. Hello, come on, people. Maybe I did, and maybe I didn't. There we go. Yeah.
Assert does not equal.
Assert, yeah, assert not equals. Yeah, exactly. Okay, so now I got this to pass. So again, the actual wrapper function is still pretty silly. It's not doing anything, and it's not doing what I intended it to do. But I'm just kind of going through simple examples of, well, these are all true. I should be able to create a wrapper. When I pass in a blank, it should come back blank. When I pass in a small string, you know, smaller than the actual line length, it should come back with just that string. So it seems silly, but I'm kind of defining what this thing should do, and I'm thinking through all of the different scenarios. So what happens if I pass in a longer word? Test can wrap long word. And I'll just copy and paste this down here. And I say long word. Now what do I expect to happen in this scenario? Well, let's see, 1, 2, 3, 4, 5. I expect it to be, actually let's just do this. 1, 2, 3, 4, 5 /n, right? Which I got to put double quotes around this so it actually knows what /n means. But in this scenario, that's what I want it to do. I want it to take the word and actually slice it off and carry it around to the next line. It fails. Actually, what I got back was long word, and I expected long W erd. So for this, we could just say, well, if the string length of the text is, greater than the line length, let's see, return the substring of text starting from 0, so the beginning, going to 5 in this scenario, the line length. Then I want it to actually add a line break. Then I want it to grab text from the line length and just return the remainder. If I don't put that third argument on there, I'll just get to the remainder. All right, so that passed. I can already tell it's not really going to do what I want it to do. There's a lot of other scenarios that off the bat it's not going to handle. But what are those scenarios? And this is where, again, we go back to the tests. So, well, what happens when I put in a test can wrap a very long, long word? And in this scenario, let's see, what do I got here? What happens when I do a very long word? And let's see here. Let's take this. 1, 2, 3, 4, 5 /n. 1, 2, 3, 4, 5 /n. Okay, so that's what I would expect to happen. Again, it fails. Why? So I expected a very long W word, and I got a very long word. I could step through this if I was confused as to why it was doing this, but I'll just explain. You know, it's basically grabbing the first one putting a line break on there, and then just giving back the rest, whatever's at the end of that. So that's not going to work. You might be sniffing a while loop maybe. I'll go through and just kind of keep looping over and tacking on the end of it. But I think a better approach might be recursion. So I'll wrap the text. If it's longer, which it is, it'll grab that first part, and then it'll take that second part and wrap it again. It'll recursively go through and continually wrap until it reaches the end and then returns. Okay, great. So that passes, and that gets that one to work. Let's see here. So what happens if public function test can wrap 2 words? What happens when I do, when I do this? Here, I'm going to break this up a little bit so you guys can read it. There we go. If I pass in word, and I'll leave it at 5. Word. Where do I want the line break? Well, 1, 2, 3, 4, 5. So what if I just put it right there? Really is what I want. I want word, and then bring it down to the second line and word. If I run that fails. Why? Well, because it left the trailing space at the end of it. So we'll fix that real quick. Let's see. Thinking trim, right? Where would the trim go? Let's see, right here. All right, excellent. All right, here, I'm just going to start copying and pasting these down. All right. Let's see. And wrap 3 words on 2 lines. What were to happen if I put word, and I said something like 12. Word. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think really in this scenario, again, we want it to actually break at the word itself. So in this scenario, I really want it to break right there. All right, that failed. So I expected word, line break, word, and I got word, whoa, erd. So now, this is getting a little bit more complicated and harder in that I have to start figuring out, well, where are the spaces? So in this scenario, what we're going to do, obviously if the string length is greater than the line length, we'll be in that case. But then we actually want to know if there's a space in the substring that I'm going to be trimming. So if, look at my notes, make sure I don't screw this up for you guys. So I'm going to use string position. So within basically what I copied there, so within the section that I'm going to be using at the beginning, if that has a space, so it does not equal 0, because strpos is just going to find the first occurrence of whatever you have here, and it's going to return the location of that occurrence, so or 0 if it can't find it. So basically, if it's
actually returns false if it can't find it.
Oh, is it false? Yeah, let's see here. Returns false if the needle is not found. Excellent, thank you. I think 0. Well, it wouldn't have worked because I did the double equals. So good catch, yeah. Okay, so if it's not false, which means it did find a space in that section, then what do I want to do? Well, I only want it to actually go to the last occurrence. So in that case, return. Let's see here. Right here, let me make this easier. So I'm going to say the last position of space, just for readability, and that's going to be strrpos. strrpos is the last occurrence. strpos is the first occurrence of text between 0 and the line length. Then throw in the line break, and then actually do that recursion again. So we're going to put this back up here. All right. Let's see. And if it didn't find a space, well, then we can continue doing what we were doing before. Let's see how good I did. Not very good. All right. Space, word, space. This is where debugging comes in. By the way, after the second talk, I'm going to be giving away, JetBrains gives me licenses to give away, so I'll have some more of those to give away. So this fantastic IDE that I use will have licenses for that. Okay, so it comes in with word, word, word. Obviously, the string length. Okay, it finds the space. The last position of the space that it found was false. Oh, I know why. Right, that's why. String position takes a haystack, a needle, and an offset, which we don't care about the offset. Okay. So let's see if that made it pass. That still didn't make it pass. Let's go back through.
It's not text, you want substring of text. So
What's that?
you still want to get the substring of text to line length. You don't want to get the last space in the whole text. You want to get this last space in the first.
In the substring. Let's see here.
First you want to get the break, then you want to make sure that you're adding the rest of that to, because you're not doing anything with that middle section.
Not doing anything with the middle section.
So you found the
Last
last
position,
break,
text 0, last position
and
of the
then you're
string.
not doing anything with the part after the break until that.
Why don't you just make it very like first part of the string and put the substring?
Yeah, you just need to change that wrapper at the end.
This right here?
Yep.
Well, it should be line length plus 1. I know that. Or not line length. No, you're right. I want this, right?
Yeah.
That's what I want.
You're still off.
There it is. That's what it was. Right, because the second part is, so it's going to grab the first part to the last position, or the last space that it found in that section.
It found the last space in the whole string, didn't look at just that section. Text is the whole string.
But that's okay. For this test, that works. See, you're thinking ahead. You're thinking ahead. Yeah, you're thinking of when I add even more words. Right, we're just solving for this case. But yeah, you could. You could. Yeah, the part that I wasn't doing was that second part going through. I need to start at the last position plus 1 because we know that last position is a space and we don't actually want the space. I'm going to go plus 1 position to get rid of that space and carry that in. Okay, so as you can see, the tests are getting harder, which is good. And actually that probably means you're getting close to the end, which is also good, as far as writing tests for this specific class. You know, one question is, what if, you know, should you write a test for something that you know will pass? So like, you know how your code's going to react, and you're like, well, should I write a test for that scenario anyway? And I would. I don't have one off the top of my head, but I know that comes up quite often, as whether you should write a test for different scenarios anyway. It doesn't hurt to, might as well. Let's see here. So, okay, so what happens when we have public function test 2 words at boundary? What happens with this scenario? One, two, three, four. 1, 2, 3, 4. Like, do we, you know, what do we expect to happen? Well, really, all right, we expect that to happen. But the trick is, and what we haven't tested before, is when we actually have the wrapping position at the boundary line. So you would think that that would pass, but it actually doesn't. Apparently puts another line break in there. And we can step through and figure out why. It's going to take word, and skip over this because there's not a space within the boundary, because remember the boundary is 4, which actually is the character before the space, so it didn't find a space. And it's going to take the first section, add a line break, and then pass in the remainder. And that remainder is, you can see up here, is space word. So in this scenario, it's just going to keep going through. It's going to find a space, and it's going to go through all of this. When in reality, it's pretty, you know, we could just say, well, let's see, what else? We might be able to just to say, yeah, text equals trim text, right? You don't think that'll do it? That you know, that made that test pass, so that's good. We could also do, there's different refactorings we can do, and you should make that part of your process. So as you start writing these, you're like, okay, this is kind of getting a little messy. There's a simple one that I can see right off the bat, which is you know, an early return. Why don't we just maybe reverse this if? And just say, you know what, if the string length of the text is less than or equal to that, so it doesn't even count, just return text. Like, don't even do all this stuff. And if that's the case,
We still want to trim first.
well, that's what we have tests for. So you're right, absolutely. See, you guys are just too good at this. You don't even need tests. See, I need tests. This is for me. I need tests because I can't figure this stuff out. So clearly, you're right. That fails. So I put that back up there. Write the test, or run the tests, and now we're passed again. So I've got all these tests in place that when I make changes like this and they fail, that's okay. Because, you know, like you found, I'll just move the trim back up to where it's supposed to be and get it working again. I could go, you know, make more changes. You know, I wonder if I can get rid of this trim. I don't know. Yeah, I can. Okay, great. And you might find that throughout your development, you know, you find a bug. Well, obviously then you'd write a test for that bug so that it never happens again. You have a little regression testing in place. Maybe the bug was something weird and you actually had to put the trim back in place. Well, go write a test so that somebody doesn't remove the trim again. So the tests we've written, how many tests we got here? 1, 2, 3, 4, 5, 6, 7, about 8 tests here. We could probably keep going. When do you stop? Well, I mean, you stop when you feel you've covered all of your scenarios. But we probably could keep going. You probably could throw maybe some lorem ipsum in there or something like that to see what would happen. But I think at this point we have a pretty good test suite, and we've covered a lot of different scenarios. Now, I also did this with, let's see if where did I put that? Yeah, here. I tried to do it like a what I'm calling traditional way, which is writing the test afterwards. And I tried to be honest, not trying to sway you one way or the other, but thought about like how would I write the test if that wrapper class was already written, and I were to write tests around it. So the wrapper class is here, it's already written, and then I started writing some tests. The way I would have written it is I'm kind of just testing the constructor, so testing that, this is kind of the same thing that you've seen before. And honestly, I'd probably just throw some text in there and test that it wraps. This is really how I would test something that's already in there. Maybe, I probably wouldn't test blank strings. And I probably wouldn't test, 2 words. And I probably wouldn't test a lot of the scenarios that we came up with to make that stinking thing pass. Maybe I would, test putting an integer in there or something like that. But my point is that the tests are going to become more meaningful when you write TDD. Hopefully, you guys can think about how you guys write tests afterwards and see that, yeah, my tests do kind of follow this convention of I would just test wrap, or you might write test an empty wrap or something, but you're definitely not going to have the same amount. Any questions?
How do you handle like if the class behavior of the class changes, like later on with your tests, if you decide to go a different route, how do you manage that?
So if the behavior of a class changes,
or a function.
or a function in the class, well then you would change the test. I mean, if you're truly changing the behavior, and and that's intentional, then you can change the test to do that. But you, right. You might go through TDD again and start over. I don't know. It kind of depends on the scenario. Obviously, I mean, if you're changing an existing function, you're probably not changing it too much, right? You're tweaking it here, tweaking it there, I would think. Or adding, yeah, okay, so adding parameters or something like that. So you would write, so hopefully the old test would still stand true, right? Especially if you're trying to maintain backwards compatibility, right? Anywhere else that uses that old function needs to still exist. So if you're adding a parameter, maybe you're saying like, I don't know, words only. I don't know, like you don't want it to break in the words. And if you're going to add that parameter, you need to, it would be good of you to add a default in there. Say, well, words only, well, before it did words only was false. It would actually break it, in the middle of a word. But now I'm building functionality that if that were true, then I would do something. So all your existing tests should still pass, and you'll write additional tests for when words only was true and blah, 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 a bunch of scenarios. But yeah, I think, there are scenarios where you might actually have to change some things.
I have a comment about that too, which is that's one of the primary reasons I write unit tests is because I'm expecting people later on to modify my code and maybe change it to do something that it's not supposed to do. And then we want to know right away, okay, you broke it. We don't want it to do that, so don't make that change before we deploy it. And one of the things that I do kind of defensively in this sense with my test is use, I believe it's assert does not equal in PHP unit, and
Assert not
ensure
equals.
that I'm not getting values that I suspect someone might try and do later on. An example recently that came up is we have usernames coming from a different system, and we have to maybe clean them up a little bit before we save them in our system. Maybe remove spaces or change underscores to dashes
Well, it depends. I think when I write new stuff, I try to, you want your tests to be small. To me, it's a code smell. If your tests are crazy long and you have to do tons of setup and all that kind of stuff, right? That means to me, it's a smell. Something's not right. There's too many dependencies. There's, something's not right. So yeah, I think your test should be small. But yes, there could be multiple assertions. I don't think that's the problem. If you're testing like a model or something like that, you might want to test that the attributes are such and that this is an integer, or and I think with unit tests specifically, they're going to be very small like this, with only a couple assertions. But PHP unit can be used for other types of tests, integration tests, and even functional tests. When you start getting into that realm where you're pulling things from a database or you're generating stuff, then those tests I think typically will have more assertions, because maybe you don't know what the value is, but it's got to be an integer, something like that, because it's auto-generated by the database and something. But yeah, try to keep them small. Naming tests is kind of hard too, but I don't know if you noticed, but like the names I used were pretty long, but they were descriptive. Typically, when you're coding something right, you want to keep your names short. But with tests, I think it's the opposite. I think you actually want them to be long and descriptive. Yeah. Right. Yeah. It's describing what it should do. And again, when you 6 months later, or somebody else, another development team member, starts to mess with the wrapper class, and the test fails, they'll go into the test that failed and go, "Oh, can wrap 2 words. Oh shoot, yeah, I did break that, didn't I? And it's supposed to wrap 2 words, or whatever." They can read right off the test what it was intended to do. And they know it was intended to do because someone wrote the test first to make sure that it does that. Not that someone wrote the test because that's what it does. Any other questions? Okay. Oh. So you're saying like things like testing empty or whatever. That wasn't what I was intending to do. So yeah. So why write? Well, because when you write these tests, you need to think about so what you intended to do. That's the happy path, right? But wrapper class is not always going to be used in the happy path manner. And I think that this goes back to coding defensively. Again, you 6 months later is not going to remember. You're not going to remember how you wrote the wrapper class or what it does, or does it check for empty strings, or you're not going to know the ins and outs of exactly. You know what it's supposed to do, but you don't know what it's going to do in certain scenarios. And again, if you work in a team, another developer might need to wrap a string, and they're going to see this wrapper class and start using it. So I think it's just a good coding practice to think about different scenarios. And run them through with tests, because it makes you think about what you want it to do. If I pass in a blank string for wrap, maybe I want it to throw an exception. The way I designed it, I didn't want it to. I just wanted to return a blank string. But it makes you think about what you actually want it to do. Maybe I want it to return false. What happens when I put in a 0? Do I want it to return a blank string, or invalid argument exception, or false? So my point is that if you think about all those different scenarios, then it makes you design it the way you intended, not the way it just happens to work out. Does that kind of make sense? Another example is, in fact, in this example. Actually, this is a bad example, but I was going to say, when I'm coding sometimes and I write tests for this, it makes me think of questions I need to ask the PO. hey, Mr. or Mrs. PO, product owner, you know, what do you want to happen in this scenario? What do you want to happen when it's a registration form and somebody puts in 123 as the name or something? I don't know. Like, do you want us to validate for, you know? So when you're writing the test for that, it makes you ask those questions, and then maybe you don't have the answer, but it makes you find the answer. Otherwise, you're going to get unintended or you know, or errors. Okay, cool. Well, that's all I had. So maybe let's take like 10 minutes and have Sheldon get all set up, and then you guys can get some more pizza, and then we'll get rolling with the next talk. So thank you.
My name's Sheldon Kreger. I work as a web engineer, primarily at Intel. I also do some side projects, including for Algorithmia. And what I'd like to share with you tonight is my hand-picked selection of 5 algorithms from Algorithmia's API, which I believe are practical and understandable for every web developer to use. So let's get started. First of all, I'd like to discuss just what is Algorithmia, because this is going to help my code examples make a lot more sense. Algorithmia is a way to outsource calling your algorithms to a separate service. So we can utilize code from other developers, and we can use infrastructure from a different team and get some advanced algorithms inside of our applications. And this doesn't involve writing the algorithms ourselves. We don't have to implement them ourselves. And we also don't have to maintain the infrastructure where we might have to run them. Algorithmia currently has over 1,000 algorithms available, and more being added all the time. Anybody can contribute an algorithm and put it on the marketplace for other developers to use. And these are just some examples of different kinds of algorithms which developers in different fields might find useful. This is what I just went over. I'll give you a second to just read through this. So in most cases, advanced algorithms are not being written in PHP today. Most of the open source libraries and a lot of more academic-oriented software is coming from Java, Scala, and Python, just to name a few. And that's why Algorithmia hosts these programming languages on the infrastructure and allows you to call them in your applications. So before you register, I don't know if anyone jumps on tonight, I can get you this code at the end. So don't register till we're done, because then you won't be able to get the code if you decide to try it out. So on to the algorithms. The 5 that I'm going to cover tonight are sentiment analysis, language detection, PageRank, nudity detection, and term frequency inverse document frequency, which is also called TF-IDF. Who here has heard of any one of these algorithms? Awesome. Yeah. So I think we're going to be off to a good start. One of the problems with having users be able to upload wherever they want to your website is the possibility of getting something inappropriate posted on. So if you run a PHP forum, for example, you may want to do something like ensure that there's not profanity. We have algorithms for that, but maybe also verify that they're not uploading nude images onto your website. In the past, this has been handled through manual moderation, but recent advancements in these algorithms allow us to do this in a more automated fashion. We have a demo website called isitnude.com if you want to try it out, and you can punch in a URL to your favorite nude or non-nude image and see if the algorithm is able to correctly detect whether or not you are getting these, whether the image is nude or not. So the basic process, and you'll have to excuse me because this is one of the most sophisticated algorithms I'm going to talk about, so that I'm not going to get into too much details on this one. But the basic process is that we scan the image looking for skin-toned pixels, and we have a library for all different skin tones. And then we locate these regions within the image. We also do a detection of the face on the image, and then we calculate the ratio of the skin tone pixels versus the non-skin tone pixels in the image. And this gives us a fairly accurate probability that the image contains nudity or not. So the basic idea is if you're wearing clothes, you're going to have some skin-toned pixels in your image, but it's not going to be in a very continuous stream. And if you, using that data, we can classify it as nude or not, and then we can also return a probability value. If there isn't a face, then this algorithm, I believe, will still work most of the time. However, this one will not work for black and white images because that.
No face, and then what if it's like a desert?
So a desert, that one doesn't have since it doesn't have a face like you're saying, it would use just the ratio of skin tone versus non-skin tone, and it could return a false. So there is possibility that you get false values returned, which is why it also returns a value for the percentage of likelihood that we believe that it could be nude. And we wouldn't rely on something like this, but this can eliminate or reduce the amount of manual review that you might have to do for your content. Another thing to keep in mind is this is pretty new technology, very recently published papers. This algorithm isn't perfect. Some of the other ones I talk about tonight work a little bit better, but it's worth playing with, worth checking out. And I'm going to show you how we can make a basic HTTP request to the Algorithmia API using PHP. This is just vanilla PHP using curl. The first part of this is the URL to the algorithm, which you'll find when you search through the library of algorithms. And then we set up the curl request, and we give it a URL to the image that we want it to test. In this case, we're not going to send the whole image over the network. We're actually going to give it a public URL that it can go check out on its own. We set the headers that the API recommends, or the API requires, and then we execute the request, wait for it to come back, and then we see what we get back. So I'm going to show you what that looks like really quick. So this is just the script that I just showed you. And this is a highly computationally intensive algorithm because it does go pixel by pixel. And so this is going to take a few seconds to come back. What we get is, for this particular image, we think that it's not nude. We have a 95% confidence rating. And then we get a little bit of metadata about the nature of the quest and how long it takes. This one takes a long time, like I said, because it's calling the nudity detection, doing the scanning there. It's doing the facial recognition algorithm, doing all that kind of stuff. So this is fairly slow. A lot of the other algorithms run much more quickly, but this one's just very computationally intensive. And so what I did when I built my Drupal module, which I'll show a little bit later, is rather than doing this when the image is uploaded by the user, I allow moderators to go back through and look at the images after they've been uploaded. Basically, go in the UI and click, say, check these images for nudes, and then run them when it's not going to interrupt any of the users in their workflow. Did you have a question? Oh, OK. So that's something we take into consideration. This is very small. I'm not sure if I'm going to. This is just my Drupal, some code from my Drupal module. The only difference here is we're not using curl, we're using a Drupal, what is it? Drupal HTTP request, but it does exactly the same thing. Whatever framework you have, if it has an HTTP request function of some kind, as long as you can set the headers and pass it the JSON and the URL and everything, it's going to run just fine. The next algorithm I'd like to cover tonight is sentiment analysis. I wrote a fun little application that gathers tweets based on a topic of your choice and runs this sentiment analysis algorithm against them and gives you an average result for however many tweets you want to gather. But this is practical, maybe not in a CMS, but if we're doing some kind of business intelligence task. Oftentimes, business people are looking for feedback on their products or on a new service they launched, and you may not have the resources, or you may decide not to use like a manual survey. You don't want to interrupt your users, or maybe you want to know what's happening on the social networks, and you want to get a more general idea of how people feel about something. This is also used quite frequently in academia and in political forecasting, economic forecasting, a lot of different applications of when we want to know how someone feels about a particular topic. And this is quite the field of research right now. The basic algorithm is, the way that it works is you take a predefined set of words, usually from an open source library today, that you know are happy words, and then you have a predefined list of words that you know are negative words, and a lot of words that you know that are neutral. And you go through word by word, and it's called bag of words, and you assign a score for each time you get a happy word, each time you get a sad word, and then each time you get a negative word, and then you average that result to get your total score to determine whether you have a overall happy sentiment in this chunk of text that you're analyzing, or an overall neutral or an overall negative sentiment for the chunk of text that you're analyzing. That's the most basic implementation. And again, if you dig into the research, or if you were to look under the hood on some of the algorithms that are out there, they're much more sophisticated than that, but the basic idea is that we're able to look at words from a pre-existing list and determine overall what is the sentiment. I was actually reading a paper when I was when I was doing some research on this, recently published by Stanford, where they are actually splitting sentences into different pieces, and they're able to then analyze statements that are dual in nature and split them up. This half is negative, this half is positive. And this is a really neat visualization of that. The algorithm for my demo doesn't do this, but I thought this was pretty cool, and it also makes a neat graphic for my slideshow, so I brought it in here. A good example is maybe a Yelp review of a restaurant saying, "I loved the food, but the service was terrible." And in that case, you would want to know, if you were a manager at that restaurant, well, our food's good, our service is terrible, we've got things that are good, things that are bad, and those are two separate things. We wouldn't want to average that to a neutral review, for example. And a really interesting visualization there where it splits at the but, and it's, pardon me there, at this word but, and then it is able to analyze this tree of words separately from this tree of words. Pretty interesting. Yes?
How would it handle something like irony or sarcasm, where what you say is the opposite of what you mean?
Yeah, so it depends on the context. So in some cases, if you have irony, then you'll actually have keywords that indicate that you're being ironic, and then you can modify your algorithm to do that. But that's a tricky thing to do, and something that is probably under active research, I would imagine, or that there's something it's possible, but it probably requires a lot of manual review of ironic sentences and comparing against those. Any other questions? My next algorithm tonight is called PageRank, and it is one word like this. It's not page space rank, because the inventor of this algorithm, his name is Larry Page, and he was one of the early employees and one of the founders at Google, so called it PageRank. And what this does is, the most famous implementation obviously is it's the underlying algorithm for the Google search engine. Granted, it's much more sophisticated than this algorithm alone today. However, the underlying assumption here is that the more inbound links that you have to a web page, the more valid people on the internet believe that page is, and the more likely it is that someone else should probably read that when they do a Google search. I'm going to go over a graphic like this in a second. Don't let that confuse you for the moment. It's also interesting to keep in mind that it's not just used for ranking Google results or doing search results in general. Any directionally modeled graph could utilize PageRank for different purposes. I don't have an example of that off the top of my head, but this is a general algorithm. It's not specific just for Google. To understand this algorithm, we need to go over just a little bit of graph terminology. For those of you who haven't taken a discrete math class, or maybe it's been a little while, we'll quickly brush up. The term node or vertex are used interchangeably in graph theory, and that indicates these little dots on our graph here. That's an item in the graph. In this case, what I have is a graph containing one user and 3 pages. And then we have edges or relationships, 2 terms that are also used interchangeably. And this exists between 2 or more nodes. So we can have different kinds of relationships between different nodes in our graph. And we can also have directionality of relationships. So to look at this small example that I created with Neo4j here, we have a user whose ID is 4 who has viewed 3 pages, page 90, page 91, and page 49 in our graph, and the relationship here being viewed. This is a one-directional relationship because the page cannot view the user. But in some cases, some graphs are going to have relationships going both ways. A good example is Facebook friendship. If you friend somebody on Facebook, they're also going to be friends with you. So you're friends with them, they're friends with you. Twitter's the opposite, one-directional relationship, where you follow somebody, that doesn't necessarily mean they follow you back. So little tricks for modeling your graph data. PageRank starts off by assigning a flat score to every node in the graph. So to use an example, let's pretend we did a Google search and it only had 5 potential results it wanted to share with us. Most likely, let's say we did a search for PHP, we're going to get many more results, but let's assume it's 5. And all of these documents, they perform some TF-IDF. They know that these documents are highly relevant for the term PHP using text analysis. And so now we have this set of documents. We have to choose which order to display them to the user on the Google results page. We start off by assigning a total score of 1 and splitting it evenly across all of the nodes in the graph. So in this case, we have 5 nodes, and therefore 1 divided by 5 is 0.2, and we assign 0.2 to every node in the graph. Now, assuming that some of these pages are linked, we would take the score for the links to relationship and move it over to the node that it links to. So in this case, we call this node A links to node C here. And therefore, because it has an outbound link going to this page, we're going to take all of its score and we're going to assign it to node C here. And this is going to be our most preferred Google result, our #1 result, if this is our entire network. And if we were to have multiple outbound links to other pages in this network, then we would then split the score, as I've visualized over here, showing we give 50% because we have 2 outbound links. 50% of node A score goes to node B, and 50% goes to node C over here, and they both get a total score of 0.3, and then we have a tie. But this is the basic idea behind PageRank. Does anyone have any questions about this? Yes?
What if B linked back to A? Or is that just a one-way thing?
So that is highly possible that B would link back to A, and then in that case, we would bring the score back over in that case.
All 3 or just?
No, just one, just the 0.1.
Oh, okay.
Right. And these are things that are highly experimental. So there isn't just one way to do this. Maybe we get better search results based on human testing if we give all the score back to A. And so that could be one implementation of PageRank for a particular kind of data set. These are all things that can be played around with and are active fields of research. Yes?
I just have a quick question.
Yeah.
So, suppose you have a page and it has, say you have like a sitemap on it that has links that aggregates all the links on that particular page, not necessarily all of them are shown, right? So, how would this algorithm handle multiple links to the same page from a single page?
Right. So you're linking to yourself, or you're linking within your own domain kind of thing?
Well, so you had a page A and you had a page B.
Uh-huh.
And on page A, you had 5 links to page B.
Uh-huh.
How does that weigh
Right.
that?
Just to reiterate the question for the microphone here. The question is, if page A, if node A here, linked to page B 5 times on the page, how would we weigh that? Again, this is an opportunity for creativity with your algorithm, because you could either do the same thing and say 1 link is as good as 5 links, or you could assign some kind of weight and maybe assign a higher percentage of the score if there's a split. Or you could say if there's only 1 outbound link, we only give it half of its points. And if there's more than 1, then we give it all of its points. And the way that we split that up can become very complex, and that's why Google invests a lot of money in doing this. Any other questions about the basic idea behind PageRank here? So before we go on to TF-IDF, I just wanted to mention an example where I thought this might be practical, which is if you're indexing search across multiple websites, multiple domains that you own into one search engine. I know I've had to do that before. Implementing your own PageRank would be a possibility. I mean, it would be quite a project. But if your search results were important enough, this might be something to play around with. TF-IDF, also known as term frequency inverse document frequency. This is an algorithm used for classifying documents. An example that comes to mind for the meetup I was at last week, the PDX data engineering meetup, was a graduate student who is performing text mining on biomedical literature to find relationships between the exponentially growing number of papers that are being published today. And using TF-IDF along with several other techniques and experimenting and finding what works best to discover patterns in these documents and the relationships between the documents. Now, the most common kind of categorization that we would have as if we run a content management system for web developers would probably be tagging, basic tagging in like WordPress, where you tag a post and then those all get classified as whatever your tag is, and then they're all related. If our users aren't doing that up front, then we can go back and perform tagging automatically using an algorithm like this by using term frequency, inverse document frequency. We can also, even if we are doing manual tagging, we may want to find deeper associations between the different pages of our own website to build a content recommendation engine. And this is something that we recently launched. I've written a WordPress plugin that integrates with the API, as well as a Drupal module, which allow you to point and click to success to utilize this TF-IDF algorithm to come up with content recommendations. So let's go ahead and show you how it works. The basic idea, I'll let you read the comic first. It's not that funny, but it's my favorite webcomic, so I had to include it. The basic idea is that documents are going to have unique words inside of them, or words that are relatively unique compared to all the other documents in your data set. So if I had, in fact, I'll just use the example from my own blog where I'm running this. I have a blog where I write about drumming and drum technique and album reviews and book reviews and my favorite companies and all kinds of stuff. And by using TF-IDF, we're able to extract keywords from my text and find associations between the documents. The more often a term appears, the more important it becomes, more important that term is for that document. The basic math works like this. Let's say that we have a blog post that has 100 total words in it, and we want to perform TF-IDF on the word JavaScript. This word appears in this particular 100-word blog post 5 times, and that gives us a term frequency of 0.05. We take the 5 total times that the word appears and the total number of words in the document, and we get this score. Now let's say that we have a blog that has 10,000 documents and 10,000 pages that we want to index, and then the word JavaScript appears at least once in 100 of these. This is a very precise mathematical example to display how this works. But then we calculate the inverse document frequency. So we compare our one blog post that we're interested in against the average number of occurrences in the whole rest of our entire website. And we get this score of 10. And then for this document, we get a total, our final answer here, TF-IDF of 0.1. Now, what we would do is we would run this for every document on our website and for whatever keywords we're interested in. And that's going to come up with separate scores for every keyword and for every document that contains those keywords. Then what we can do is we can compare them. So a blog post that has the word JavaScript in it 5 times is going to have a higher relevancy using this algorithm than a document which contains JavaScript only 2 times, assuming that the length of the actual blog post is exactly the same. Yes?
Is this particular algorithm case sensitive? Is it going to match lowercase JavaScript?
That's an excellent question. This is a problem that comes up in data science in general, but particularly in text mining, where before we perform this kind of analysis, we need to clean up and standardize the data that we're working with. So in this case, before we run our blog posts through this algorithm, we would lowercase all of the word. We basically standardize the document. We would remove all the abbreviations so that our our words are all separated only by spaces and not by things like periods and commas and stuff, then we would turn them to all lowercase. And then depending on the library we were using, it may also be useful to combine words into phrases and then treat the phrases as words as well. So that's something to take into consideration. And again, this is a room for creativity and is an active field of research right now, where we can play with those kinds of variables, change the input coming in, standardize it in different ways, and perform TF-IDF or other algorithms to get the answers that we're looking for. Does that answer your question? Yeah. Yes.
So, will the algorithm have any capability to detect people who are trying to game the algorithm? You have bad actors in there who spam their own site with the random pages with a certain keyword they want to rank high.
Yes. That's an excellent question. I'm going to reiterate the question for the microphone. I was asked if this kind of algorithm has the capability to find somebody who's gaming the system, who will insert the keywords into their documents many times in order to boost their search results rankings. And I'm sure Google has dealt with this, and it's probably been a very expensive problem for them to handle, as well as other search engines. Because people try and cheat. They try and put the term JavaScript. If they want to rank highly for JavaScript, they'll put that word in there many times, and perhaps this will give them a better search result. The answer to that question is you have to actually, as part of your cleanup process, look for this kind of cheating. And so when Google has, for example, they've rolled out these major updates to their algorithm, and these SEO experts get a little bit nervous because their strategies might not work anymore. And this is exactly what Google is doing, is they're modifying their algorithm in order to handle people trying to game the system based on their knowledge of the algorithm that Google is using. So for my own website, I don't try and game my own blog posts. So this really basic TF-IDF algorithm works really well. But for a more sophisticated system, working with a huge number of documents, the entire internet, obviously this is much more challenging. My computer's shutting down. There it is. OK, question over here.
In your experience, what's a useful sample size? How big a block, how large a document, how big does a document have to be for it to make sense to parse, to have a sensible signal-to-noise ratio?
Yeah, excellent question. So just to reiterate the question for the microphone, the question is, how large of a document set would we need to have in order to get relevant results? And perhaps what about the length of the documents themselves? And that's something that is going to be, it depends highly on the nature of the diversity of the material contained inside of your corpus, inside of your set of documents. So if you have a wildly diverse blog that's about programming, and like one of my blogs is like programming, Olympic weightlifting, drumming, book reviews, just all kinds of random stuff. And I only have like a blog post or two about each one. That might be more, it could be that an algorithm like TF-IDF doesn't classify those as well because it's a small sample size and there's only a certain number of documents that it can compare against. So these numbers, this final score, the answers become really, really close together is the problem. And you don't really get a clear answer. Or perhaps JavaScript, like this term only appears once on my entire blog. So that's going to ruin, you're only going to get one score, and so you're not really going to get relevant results. Does that answer your question? It's it's not really a satisfactory answer. It depends. It's worth trying out, I would say, regardless of size and the diversity of your blog posts. But more can be better. Yeah.
Question?
Yes.
How about in many-to-many scenarios where I have a master document with many terms in it, and I have 1,000 slave documents that have various terms, I can find the most relevant slave to the master based on matching of all the words and all the components within the master. Given a scenario, it would be like a job description versus 1,000 resumes. How do you match out how good is this algorithm at determining, of ordering all of those resumes in the most applicable to the least applicable as it relates to the document of the job description?
Okay, so the question is, if I have a document that has a list of keywords, for example, a job posting that had the word JavaScript, PHP, senior developer, 5+ years experience, bachelor's degree, and then I had a set of documents that were resumes, and I wanted to filter through them and say, I want the resumes that match my job description the most closely to be filtered to the top so I don't have to look through all of them. Excellent example, by the way. This is actually a very good algorithm for that kind of problem because you choose the keywords that you want to analyze. So you would choose PHP, you would choose JavaScript, you would choose senior developer, etc. All the ones that you're interested in that are inside of your original document, you get to select those, and then it's actually separate. You choose the keywords, and then you perform the analysis on your corpus, on your set of resumes. And you would use a more sophisticated, rather, you wouldn't just look at one TF-IDF score. You'd have to find a way to combine them all together and get an average. And that's where the creativity for your particular problem would lie, is let's say that I had somebody who had PHP but not JavaScript in their resume, but they wrote the word PHP like 30 times or something. How does that weigh out against somebody who has a more balanced resume with PHP, JavaScript, blah, blah, blah? Those kinds of questions are highly contextual, and that's where the data scientist gets to have a lot of fun, is in handling those kinds of challenges. Does that answer your question? So you perform a TF-IDF for each term that you're interested in, and then find a way to average them in the way that makes sense for your purpose. Any other questions about term frequency, inverse document frequency? Yes?
I understand how term frequency would work in the scope of an API, because I would just have to send you one document. But if I have 10,000 documents, am I making a single API request with 10,000 documents included, or is there some kind of state to the...
Right. So for this particular implementation, I'll show you how it works. This actually will automatically scan your entire website. It'll crawl your entire website and gather all the documents that you mark as something that you want to have included in your corpus. Your own implementation, or perhaps another implementation that's on Algorithmia, you would actually send it every document that you want it to analyze in your JSON. Does that answer your question? Yeah. So let me show you what the results look like on my blog. All right, so this is a very standard Drupal 7 site. I have, I believe, just about 100 blog posts, nothing too crazy. My favorite example of this at work is my fascination with this symbol brand Peisty. It's one of my favorite brands of symbols. But this term Peisty, that's a really unique word. That's not something, if I'm writing about drumsticks, I'm not going to say Peisty. If I'm not writing about, if I'm writing about snare drum rolls, I'm not going to use the word Peisty. But when I'm talking about symbols, I'm probably going to use the term Peisty. So if we look at the recommendations that it returns, a lot of these actually, like Achilles Priester, I mentioned that he's a Peisty artist. He's a signed artist with Peisty. Hi-hat symbols, Peisty makes some of my favorite hi-hat symbols. And in this blog post, I also mentioned Peisty. So what it did is it found one of the most unique terms in all 100 blog posts that I have. And then for this page, it was able to say, okay, this is the unique term. This particular page we're on has that term, and so we're going to give you results for other pages that contain that term. And that was kind of the end result that I ran into with this implementation. What I like about this, the module that I set up.
You're just
Yes.
searching for a keyword in documents in that case, right? You're returning a list of hits.
Well, I'm actually doing a bit more. The question is, am I just searching for keywords in the document and searching for hits?
That context around your word
Yeah,
is
so
more meaningful.
the difference is I never had to search for the word Peisty. It scanned through the documents and it found the word Peisty all on its own and was able to automatically associate the documents because that term is unique in all of them. It's kind of a tricky, kind of a nifty thing to do.
Yeah, because you've got lots of other words in there. Right?
Yeah, because
So
if I wanted to
you picked
hashtag,
the most unique one and said, this is the word that should define all the related content.
right, yeah. And because if I just wanted to do tags, I could just tag all my stuff that were Peisty, and then I could, instead of running this algorithm, I could just put a block up that lists all the blog posts with hashtag Peisty on it. But this is just a little bit more sophisticated than that. So how much time? Okay, so quickly I'll just show you. It's neat in Drupal 7 because this is what's called a block. How many people have used Drupal 7? All right. So you install the module, enable it, give it your API key, and then you set the block in whatever region of your theme that you want it to exist. And it's actually going to insert some JavaScript inside of that region. And then I can use the standard Drupal stuff to determine where I'm going to display this block, what kinds of pages I can say, don't include it on certain pages, do include it on some pages. I can do it by content type. I have book reviews, I have product reviews. I could say, if I had a site administrator, I don't want them to see it. All these standard Drupal options. And then if you're familiar with the panels or Panelizer, I also have integration with Panelizer. Probably doesn't mean much to a lot of people here. But what this does is it inserts some JavaScript. Let me see if I can get this to show up. And yeah. So this is the magic. Basically, they wrote the JavaScript. You just include it on your site, and then it automatically crawls your site for you to get these recommendations. Does anyone want to see anything else? Any other questions about content recommendation with TF-IDF? There are many other methods to do content recommendations. This is just a very easy one to implement. Yes?
Well, just a quick question. So say you have this plugin installed. Is there any way to sequester certain posts or post ranges that you don't want the code to fall through?
Yeah. So that's what the block configuration I showed. I can do exclusion on pages. I can include on certain pages. That's something that is actually done on the Drupal side of things. Basically, wherever you include the JavaScript in the DOM, any page that you include it on, it's going to index that page for the algorithm. And then when it finds it, it'll crawl that and include it. So if you wanted to just do it on certain pages on the site, you just put the JavaScript only on those pages, and those are the only ones that get indexed. Yes, so the first time you run this, it's going to be pretty slow because it's going to have to crawl your site, all the pages where you include the JavaScript, and then it's going to have to perform the TF-IDF and then deliver the results back. Could take a few minutes, but then after that, it caches the results for a period of time. I believe 24 hours is the default, and then it just loads relatively quickly. Also, on my Drupal module, the JavaScript actually loads asynchronously, so the page loads and then the recommendations come up later.
So in this case, what are some of the statistics here? How many blog postings is it looking through for this word?
On my blog's very small. There's only about 100 posts here. So when I installed it, I don't remember how much time it took to run the first time. Obviously, the more pages that you index, the longer this is going to take to run, both in terms of the crawling step and in terms of the performing the, executing the algorithm step. But again, it caches the results, so when the page loads, it just fetches them the next time. Yeah. Just one of many ways to implement content recommendations. For me, I like it because it's convenient and it works decently well. All right. Let's see. Last algorithm is a little bit boring, just detecting language. This could be practical. Again, if you're indexing search, if you're indexing many sites and you don't have like a standardized way to, like by URL or something, to detect the language, when somebody searches, you probably only want to give them results back for the language that they searched in. So this is, again, could be used to classify documents based on the language that the documents are in. It's frequently used in conjunction with other natural language processing algorithms because most of them are going to be language contextual. And so if you're mining data in multiple languages, you're going to have to divide your documents up into which languages they are before you perform text analysis on them. For example, if I was mining a set of documents like published research papers in neurobiology or something, maybe some of those are in Spanish, maybe some of them are in Chinese, etc. But the group of documents I was handed, they're not divided, and there's no standardized way for me to find that. This algorithm like this would work really well. Again, this word corpus comes up. That's the body of documents that you were analyzing. And so the basic idea is that we choose a set of words that we know are most likely to only appear in the language that are unique per language. And then we can classify it that way. Relatively simple. This works really well if you have a document with a lot of words inside of it, because words and phrases that are unique to English in a computational manner, if you have a lot of words, it's a high probability that you're going to match against those when you scan the document and go, oh, that's English. But wasn't accurate enough, so what researchers have done is they've come up with this n-gram algorithm, which actually divides, instead of dividing it words, it divides the document into groups of 3 or n number of letters. The one that's available on the Algorithmia API right now is a 3-gram implementation from a very popular Java library. So it actually will divide your document up into groups of 3 letters, and that's actually a more effective way to check for the language than to compare the words themselves. Kind of interesting computational thing. Does that make sense to everybody? Any questions about language detection? So once again, I just want to thank everybody for coming out. Thanks, John, for hosting and doing the amazing live coding. Haven't seen anyone do that in Meetup a long time. And thanks to Motorsport for hosting me. If anyone's interested in trying this out, you can use this code when you sign up and get $50 of free credits. If you have any questions about algorithms or how this all works, it doesn't have to be specific to Algorithmia. This is just a passion of mine. Just let me know, and I'm more than happy to help out.